We're living in this incredible age of AI. We have these models that can do things that feel like magic. But what if I told you we're using them, well, all wrong? It's like we've built the world's most powerful sledgehammer, and we're using it for everything, whether it's breaking concrete or hanging a tiny picture frame. Sure, it gets the job done, but it's just incredibly wasteful. Well, a brilliant new research paper might have just found a much smarter way to build AI teams that actually fit the job.
So here's what we're going to cover. First, we'll dig into this one-size-fits-all problem. Then, we'll get into the wild new solution they came up with called the Agentic SuperNet. We'll look at how this AI actually adapts on the fly, check out the incredible results, both in performance and cost, and finally, talk about why this could seriously change everything.
All right, let's set the stage. Right now, the big thing in AI is building these multi-agent systems, basically teams of AIs working together. But there's a huge, fundamental flaw in how we're doing it. And it all comes down to this one question. Why are our best, most powerful AIs so unbelievably inefficient? I mean, yeah, they get amazing results, but the cost in computing power, in energy, and actual dollars is just astronomical. The problem, it turns out, is in their rigid design.
This is the perfect example of what I'm talking about. On the left, a super simple math problem. On the right, a really complex request to code a whole website. Right now, our best systems would build one single, super complicated AI team and throw it at both of these problems. It's like calling in a SWAT team to help you find your car keys. Yeah, they'll find them, but it's just complete overkill. So here's the core of it. The way we've been doing things is we design one static, one-size-fits-all system, and we optimize it to solve the absolute hardest problems it might face. But that means for all the easier tasks, which is most of them, it's way too powerful and way too expensive, leading to just a massive amount of waste.
Okay, so to fix this, these researchers proposed something totally different. I mean, they didn't just tweak the old method. They basically threw out the rulebook and started from scratch with this radical new idea.
And they call it the Agentic SuperNet. Now I know, that sounds super technical, so don't worry about the jargon. The idea itself is genius. It's not one single AI system. Think of it more like a whole universe of all possible AI teams, from the simplest two-step process to the most complex Rube Goldberg machine, all existing as potential within one single framework.
This quote from the paper just nails it. They're saying, hey, instead of trying to find one perfect needle in a haystack, let's just optimize the entire haystack. They learn how all the different pieces connect so they can pull out the exact right combination for any job, anytime.
Okay, here's the best way to picture it. Imagine an AI workshop, but instead of just that one giant sledgehammer, this workshop has everything. Tiny screwdrivers, wrenches, drills, complex diagnostic machines, the whole shebang. The Agentic SuperNet is that entire workshop. And it comes with a master architect, a controller AI, that looks at a job and in an instant assembles the perfect custom toolkit to get it done right.
So, a universe of AIs, a master architect, it all sounds great in theory, right? But how does it actually work? How does this thing pick the right tools and build a custom AI team on the fly for every single question you ask it? Well, the process, which they call MASS, is actually pretty straightforward. It happens in 3 steps. First, the controller AI analyzes your question and picks, or samples, the right workflow from that SuperNet. Second, that brand new custom-built AI team gets to work and solves the problem. And third, and this is the really clever part, the system gets feedback on how well it did and uses that to evolve. It's not just learning answers, it's learning how to get better at problem-solving over time. So let's say an easy query comes in, like a simple math problem. The controller AI looks at it, says, yep, this is easy, and assembles a super simple 2-step team. Maybe it just takes the input, gets an output, and decides we're done here. It's fast, it's cheap, and it's efficient. No wasted effort. But now, check this out. A much harder query comes in, that complex coding task. The controller immediately recognizes the difficulty and assembles a powerhouse team. It might pull in an agent for step-by-step reasoning, another one that knows how to use coding tools, and maybe even a debate module where different AIs argue over the best code. It uses way more resources, but it's exactly the right amount for that specific job. That right there is smart, dynamic adaptation.
Okay, so the system is way more flexible, it's smarter, but does it actually get better results? This is where it gets really exciting. Because it turns out, being this efficient doesn't just make it cheaper, it actually makes it better.
Let's just look at the raw numbers.
Across all these really tough benchmarks, from math puzzles to generating code to using complex tools, this MOS system consistently beats the best systems that came before it. And it's not just by a little bit. Look at the GIAI benchmark. It's better by over 4 percentage points. That's a huge leap. It's somehow achieving the best of both worlds, top-tier performance, because it's so efficient.
Now prepare for your jaw to hit the floor. Let's talk about cost. Training this system is just ridiculously cheap. To train it on that math benchmark, it cost about $3.38. The previous best system, $22.50. That is an 85% price drop. Suddenly, building these incredibly advanced AI systems is something way more people can actually afford to do.
And if you thought that was good, the savings when you actually run the AI are even crazier. We're talking up to 94% cheaper per question than some of the more complex systems out there. It's even 75% cheaper than the best automated one. This is what turns a cool lab experiment into a real-world tool that can handle millions of users without bankrupting you.
This chart just says it all. You want to be in the bottom right corner. High performance, low cost. You can see all the other systems are stuck in that trade-off. Either they're good but expensive, or they're cheap but not as good. And then there's MOS, all by itself, pushing into that perfect spot. It's not just a little better, it's playing a whole different game.
So, what do we have? A system that's more accurate, way cheaper to train, and way cheaper to run. This isn't just a small step forward. This research points to a completely new direction for the future of AI. But the real genius here, the secret superpower of this whole thing, isn't just about efficiency. It's what the system is actually learning. See, it's not just memorizing answers to problems, it's learning the deep, fundamental strategies of how to solve problems in the first place. It's learning when to think step by step, when to grab a tool, and when to just give a simple answer.
And because it's learning those core strategies, its knowledge is unbelievably flexible. For one, you can train it on one model, like GPT-4, and then swap in a totally different one, like Llama 3, and it still works great. It also generalizes across tasks, meaning strategies it learns solving math problems help it write better code. And maybe the most amazing part, you can give it a brand new tool it's never seen, and it just figures out how to use it.
So, what does this actually mean for us? Well, the real-world impact is huge. Imagine a smart tutor that gives a simple explanation for an easy question, but a deep, complex lesson for a harder one, perfectly adapting to the student. Or a coding assistant that gives you a quick one-liner for a simple task, but deploys a whole debugging team for a massive bug. This makes that kind of powerful, custom-tailored AI cheap enough for everyone, from scientists to students.
So when you boil it all down, the big takeaway is this. Maybe we've been thinking about AI all wrong. Maybe the future isn't about building one single, perfect, all-knowing mind. Maybe it's about building a system that can create millions of tiny, perfect teams on demand, each one custom-built for the exact problem it needs to solve. It's a really powerful shift in thinking. So the only question is, what problem would you give them first?